Hey there guys, welcome to my walkthrough of the AQA June 2018 Level 2 GCSE Further Maths Paper 2, which is the calculated paper. I've done paper 1, a link to that will be down below. Lots of useful stuff will be linked in the description, so be sure to have a gander down there. Okay, let's get cracking. Okay, question 1. If the nth term of a sequence is 1420 minus 5n over 1420, add 5n. Part A wants us to work out the position of the term that has the value 0. So the position means which number term is 0. So, all that we do is set the nth term equal to 0 and solve for n. Okay, so because we're equal to 0, we can multiply both sides by the denominator and it's gonna disappear. So we'll get 1420 minus 5n is equal to 0, add 5n, 1420 is equal to 5n, and then finally divide by 5 and we will get n is 284. So it's the 284th term. Cool. Part B wants us to write down the limiting value of the sequence as n tends to infinity. So, how we do this is if we divide the top and bottom by n, we're going to get 1420 over n minus 5 over 1420 n add 5. Now, as n tends to infinity, 1420 over n tends to 0, and thus 1420 over n minus 5 over 1420 over n plus 5 is going to tend to minus 5 over 5, which is minus 1. So the limiting value is minus 1. Cool. Okay, question 2. P minus 3 minus 10 and Q, A, B are points on a straight line with gradient of 12. We want to work out one possible pair of integer values for A and B. Okay, so gradient M is difference in y over difference in x. So the gradient of PQ is equal to B minus 10, so B plus 10 over A minus 3. So that's a plus 3. Now we need this fraction to equal 12. So, for example, we could have the top, let's say, as 24. So, if we had b plus 10 is equal to 24, and to get 12, we would need 2 on the bottom. So, if b plus 10 is 24, b, it would be 14, and a, if a add 3 is 2, and then a is minus 1. So q could have coordinates minus 1, 14. Cool. Question 3, we're told that p is m add 2 over m squared add 1. We want to work out the value of p when m is minus 5.5. So we will get p is minus 5.5 add 2 over minus 5.5 squared add 1. So that is going to be minus 3.5 over 5.5 squared. It's the same as minus 5.5 squared. Add 1. Use your calculators. And we will get, bear with me, we will get minus 0.112. Cool. Part B wants us to work out the value of m when p is 2. Okay, so this way around, we're going to have 2 is equal to m add 2 over m squared add 1. Okay, multiplied through by the bottom, so we get 2m squared add 2 is equal to m add 2. Now we got a 2 on both sides, so we can take that away. So we get 2m squared is equal to m. Take away the m, don't divide through by it, this is quadratic. If we divide through by m, we lose a solution. So we get 2m squared minus m is equal to 0. Factorise, we get m times 2m minus 1 is equal to 0. So either m is equal to 0 or 2m minus 1 is equal to 0. Now if 2m minus 1 is equal to 0, add the 1. 2m is 1, m is 1/2. So m is 0 or 1/2. Cool. Question 4, we got a cheeky little 1 mark multiple choice circle theorem question. So A, B, C and D are points on a circle. So we can see we have an arrowhead going on and a cyclic quadrilateral. Now, we've got some statements and we want to tick the correct one. So let's just see what's going on. So using the old arrowhead theorem, we can say that W is equal to 2x. So that's good. And well, we know that y here is part of angles on a straight line. So we know this angle is 180 minus y. Okay, so let's see. So first statement, x and y is 180 and w is equal to 2x. So that's not right. Angles or opposite angles in a cyclic quadrilateral add up to 180. So in terms of x and y, we can say that x add 180 minus y is equal to 180. So we can actually say that x minus y is 0. We take away the 180 from both sides. Okay, so it's not this first one. What about the second one? X and y is 180, so we know that that's wrong straight away. X is equal to y and w is 2x. So that is our winner. If x minus y is equal to 0, we can add y and get x is equal to y. So x does equal y and w does equal 2x. So this is our guy. Cool. Okay, question 5, we got a piecewise function and 4 marks. So on the grid, we want to draw the graph of f of x, where f of x is doing different things for different values of x. So, first of all, f of x is x plus 4, 4x from minus 4 to 0. Okay, so, here then, when x is 4, minus 4, so when x is minus 4, f of x is minus 4 and 4, so 0. So let's plot that point, minus 4, 0. So that's that. Okay, then when x is 0, f of x is equal to 0 and 4, which is 4. So let's also plot 0, 4. So there's 0, there's 4. So let's join those 2 points with a straight line. Okay, so there is the first part of our function, or our graph. Okay, next, f of x is 4 minus 3x for x between 0 and 2. So, when x is 0, again we get 4. So let's see what it is when x is 2. So when x is 2, f of x is 4 minus 3 times 2, which is 4 minus 6 is minus 2. So let's plot the point 2 minus 2. So that's going to be there. And then join that point to this point up here. So, something like that. Just sharpen it up a bit. Okay, and then the third bit, we are told that f of x is minus 2 for x between 2 and 5. So, that is just a horizontal line. So we know when x is 5, f of x is minus 2. Let's write that down. So when x is 5, f of x is minus 2. Now that's also true when x is 2, which we already knew from this guy. So now we just need to point there and join those two up with a straight line. So there is the graph of f of x. Cool. Question 6, we have functions. So my function stuff will be down below. So we're told that f of x is equal to x squared minus 7 for all values of x. G of x is 1 minus 3x for x greater than or equal to minus 4, but less than or equal to positive 4. Part A, for 1 mark, wants us to work out the range of f, giving our answer as an inequality. So a range of a function is all the possible values that you can make by substituting the allowed values of x into the function. So probably the easiest way to see this is to draw the graph of f of x. So x squared minus 7 is just x squared translated down 7 places. So the y-intercept is going to be minus 7. So that means the minimum value of f of x is minus 7. Now there's no maximum value because the graph just keeps going up and up and up. So we say the range is such that f of x is greater than or equal to minus 7. Cool. And part B wants the range of g of x, giving our answer as an inequality again. So remember, g is bounded by x equals minus 4 and x equals 4. Now, 1 minus 3x is a straight line. So to find our range here, we substitute in the x bounds. So when x is minus 4, g of x is 1 minus 3 times minus 4, which is going to give us 1 add 12, which is 13. When x is positive 4, g of x is 1 minus 12, so minus 11. So the range of g, and let's also give a little sketch of the graph, because it's good practice. So 1 minus 3x has a negative gradient and a y-intercept of 1, sorry. So the graph is going to look something like this. Now we know when x is positive 4, the y value is minus 11, and when x is minus 4, the y value is 13. So the range is g of x is greater than or equal to minus 11, less than or equal to 13. Cool. Okay, then part C wants us to solve 2f of x is equal to g of x. We must show our working, giving our answers to 3 decimal places. So answers screams quadratic, which we already know because f of x has an x squared. So 2f of x is 2 lots of x squared minus 7. So that's 2x squared minus 14. So 2f of x is equal to g of x means 2x squared minus 14 is equal to g of x, which is 1 minus 3x. Now, as this is a quadratic, we need to get everything on the same side with a 0 on the other. So, add the 3x, subtract the 1, we get 2x squared, add 3x minus 15 is equal to 0. Now, in the question, they've told us to give our answers to 3 decimal places. That is telling us you can't factorise this, so use the quadratic formula, which I believe we are given, but we should know it anyway from normal maths. So A is 2, B is 3, C is minus 15. So the formula tells us x is minus b plus or minus root b squared minus 4ac. Don't forget my formula sheet is down below as well. You can download that, print it off. It's a good time. All over 2a. So we are going to get x is minus 3 plus or minus root 3 squared, which is 9, minus 4 times 2, so that's minus 8, times minus 15, it's going to give us positive 120, all over 2 times 2, which is 4, So we get x is minus 3 add root 129 over 4 and x is minus 3 minus 129 over 4. So let's see what we get. Bear with me. Okay, so we get 2.089 and for the other one we get minus 3.589. Cool. Okay, question 7, we have a trapezium on a grid. Now, on top, the two y coordinates are A. Now we're told the area of the trapezium is 63 square units. Find the value of A. So, area of a trapezium is, so we usually call the top length A and the bottom length B. So the A here has nothing to do with the A in the question. And we call the height H. So the area is height times A plus B all over 2. So we can work out the two horizontal lengths. So along the bottom, our x coordinates are 2 and 10. So that means the length of the base is 8. The length of the top side is from 5 to 9, so that's 4. Now we know the height of the trapezium is A, because A is the y coordinates. So we know then the area is A times 4 plus 8, so 12 over 2. Now we know that is equal to 63. So on the left, A times 12 is 12A. 12A divided by 2 is 6A. So 6A is 63. Divide 3 by 6, we get A is 10.5. Cool. So now the fun ones are starting. So we got a sketch of triangle ABC. Point P is a point on the line AB. Now we're told that AP to PB is 3 to 1. We want to work out the length P to C, giving your answer to 4 sig figs. So, what we actually want is the length from P to C. Now, to be able to work that out, we need to know the coordinates of P. So, what we know then is that P is if APPB is 3, 2, 1, that means we are breaking the line AB into 4 equal parts. Now, PB is 1/4 of AB. We know that because it's one of the 4 equal parts. So, let's think of this as a big triangle, and we can break this into 2 smaller triangles. Now, the reason we've done that is we can work out the whole length between A and B. So 7 down to 1 is 6 long. So this whole length along the bottom is 6. Now we know the length horizontally between B and P is 1/4 of that, which is 1.5. Now that allows us then to work out the x-coordinate of P as being 1.5 less than 7, which is 5.5. And then very similarly, we can get the y-coordinate. So we know the whole height between B and A is from 1 to 6, which is 5. And we know the height between B and P is 1/4 of that. So 1/4 of 5 is 1.25. So the y-coordinate of P is 1.25 up from 1. So that's 2.25. So now we know the coordinates of P. I'm going to pull out a fresh sketch of a right angle triangle connecting P and C. So, we're just going to make it a right angle triangle. So we know the coordinates of P are 5.5, 2.25, and the coordinates of C are 9, 12. Now what we need to do is, this is a right angle triangle, so if we work out the height and the length, we can then use Pythagoras. So the length is from 5.5 up to 9, so 9 minus 5.5 is 3.5. And the height is 2.25 up to 12. 12 minus 2.25 is 9.75. So, PC squared is 3.5 squared add 9.75 squared. Now that's going to give us BC squared is equal to, bear with me, so that's going to give us 107.3125. So then we need to square root that. So BC is the square root of that. Which to 4 significant figures is 10.36. Cool. Okay, question 9, we have differentiation. So I've got plenty of stuff in this in my playlist down below if you're rusty. So y is 2x to the power 7 add 15x squared all over 3x. We want to work out the value of x when dy by dx is equal to 133. 4 marks. Okay, so first of all, y has a common factor of x. So we can say that y is 2x to the power of 6 add 15x all over 3. So what we've done there is divided through by the common factor of x. Now, because we have an addition on top of the fraction, we can split it into 2 fractions. So we can say y is 2x to the power of 6 over 3 add 15x over 3. So that is 5x. Now, what we need to do here is differentiate to get dy over dx. So, dy by dx. So, the power of 6 comes down and multiplies 2. So we get 12x, and the power of 6 goes down by 1. So it's now 5. And then we got over 3. And then 5x just differentiates to 5. So this is 12 over 3 is 4. So we got 4x to the power of 5 add 5. Now, we want to find x when this is equal to 133. So 4x to the power of 5 add 5 is equal to 133. Take away the 5. 4x to the power of 5 is 128. Divide by 4. X is equal to, x to the power of 5 is equal to 32. And then finally take the 5th root and we get x is 2. Cool. Question 10, 5 marks, matrices, yay. So, the transformation matrix A, B, 2a, 3b, maps the point 1, minus 3 onto the point 1, 4. We want to work out the values of a and b. So what that means is, when we multiply the matrix by the vector 1 minus 3, we get 1, 4. So, AB to a 3b times 1 minus 3 is equal to 1, 4. So, this is very quickly going to turn into simultaneous equations. So, to multiply matrices by a vector, first of all, we multiply the vector by the top row. So we're going to get 1a, so that's just a. So we're going to get a minus 3b, and then we multiply the vector by the second row. So we do 1 times minus 1 times 2a, which is 2a, and then minus 3 times 3b, so minus 9b. Now we know that that is equal to 1, 4. So now we can get rid of the vectors. It's now just simultaneous equations. So a minus 3b is equal to 1, and 2a minus 9b is equal to 4. Okay, so let's call them 1 and 2. It's the cool thing to do. Now we need the same amount of the same letter, so I'm going to multiply equation 1 by 2. So that's going to give me 2a minus 6b is equal to 2. And I'm going to call that equation 3. Now I can get rid of the a's. I'm going to do equation 3 minus equation 2. So 2a minus 2a cancels out. Minus 6b minus 9b is minus 6b. Add 9b, so that's 3b. And then we got 2 minus 4, and that's going to give us minus 2. So, we get from that b is minus 2/3. Now we can work out what a is. So we know that a minus 3b is 1. So a minus 3 times minus 2/3 is equal to 1. Minus 3 times minus 2/3 is positive 2. So A add 2 is 1. So A is minus 1. Cool. Question 11, quite a nice one for further maths. 3 marks, wants us to expand and simplify fully x add 2 times x add 3 times x add 4. So, the trick to doing triple brackets is don't do triple brackets. So just do 2 brackets first, so let's do x add 2 times x add 3. Make sure that you can get that to be x squared add 5x add 6. So then we want to do x squared add 5x add 6 times x add 4. Now, for a quadratic times another bracket, I highly recommend using a table. Organises things nicely. Make sure that you do everything in a nice organised way. So, put x squared, 5x and 6 across the top, and then x and 4 down the side. Change colour so it stands out. Okay, so now we're doing x times x squared, x cubed, 4 times x squared, 4x squared, x times 5x, 5x squared, 4 times 5x, 20x, x times 6, 6x, 4 times 6, 24. So, now we can pick everything out of the table. So we got 1x cubed. Now, what this also does nicely for us is arrange common terms diagonally next to each other. So we can see we got 5x squared add 4x squared. So we got 9x squared. And then we got 20x add 6x, 26x. And then 24 on the end. Cool. Question 12, 7 marks altogether, part A, 3 marks. Algebraic fractions, we want to write 7 over 9x add 2 over 3x squared as a single fraction in its simplest form. So, probably the easiest way to go would be common denominators. So, let's do it a bit at a time. So let's turn that 3 in the second one into 9. So we get 7 over 9x add. Now to turn that 3 into a 9, we need to multiply top and bottom by 3. So we're going to get 6 over 9x squared, and then we need to turn the 9x into 9x squared. So to do that, we multiply the top and bottom by x. So that's going to give us 7x over 9x squared add 6 over 9x squared. Now we have common denominators, we can just add the tops together. So we got 7x add 6 over 9x squared. Boom. Part B, for 4 marks, wants us to show that x to the power 4 over x add 4 times x add 2 over x divided by x squared over 3x add 12 can be written in the form ax squared add bx, where a and b are integers. Right, don't do it all in one go. So let's just worry about x to the 4 over x add 4 times x add 2 over x. Now the trick with algebraic fractions is always to factorise them. So when we do this multiplication, we're not going to expand any brackets, we're going to keep it factorised. So this is x to the 4 times x add 2 over x times x add 4. Now what we are going to do is cancel out any common factors. So here we have a common factor of x between the x to the 4 and x. So this is x cubed times x add 2 times x add 2 over just x add 4. Okay, so there's nothing else we can do there. So let's now get the last bit involved. So we've now got x cubed x add 2 over x add 4. Now, if you divide by a fraction, you flip it and multiply by it. So we're going to multiply by 3x add 12 over x squared. So we're going to get up on top, we're going to get x cubed times x add 2 times 3x add 12 and on the bottom we're going to get x squared times x add 4. Okay, so now we want to cancel out any common factors. So, x cubed over x squared is just going to leave us with an x on top. So we got x times x add 2 times 3x add 12 over x add 4. Now, this last bracket on top has a common factor of 3. So I'm going to pull that out and put it at the start. So we got 3x times x add 2 times x add 4 all over x add 4. Now we have a common factor, top and bottom, of x add 4. So that divides away, leaving us with 3x times x add 2. So if we expand that, we get 3x squared add 6x. Job done. Okay, question 13. We have a sketch of y equals tan of x for x between 0 and 360 degrees. True story. We were asked, part A, how many solutions of tan of x equals k, where k is greater than 0, are there between 90 degrees and 360 degrees. So, let's say then k is just some point here. We draw a straight line across. Now, everywhere it hits the curve is a solution, but we only want between 90 and 360. So the only one that we care about is that one there. We don't care about that one there because that's between 0 and 90. So the answer is 1. Okay, then for part B, we are told P is between 0 and 1. How many solutions of sine of x equals P minus 1 are there between 0 degrees and 180 degrees? You may use a sketch graph to help. Thank you, very kind. Okay, so if P is greater than 0 but less than 1, and then P minus 1 is greater than minus 1 and less than 0. Now, let's sketch sine of x. So we only need it between 0 and 180. So there's 180. Now, we know then that sine oscillates between 1 up there and minus 1 down below, but our graph doesn't go that far, so we don't really care. Now we know that P minus 1 is somewhere between minus 1 and 0. So it's somewhere down here. Now between 0 and 180 degrees, a straight line going across is never going to hit sine of x between 0 and 180 degrees. So the answer is a big fat 0. Okay, then part C says state the coordinates of each point where the graph y equals cos x for x greater than or equal to 0, less than or equal to 360, intersects an axis. So let's sketch cos x like this. Again, it oscillates between 1 and minus 1. So we got 3 points. We got this one here, this one here, it happens at 90 degrees, and this one here, to 270. So the coordinates are 0, 1, 90, 0, and 270, 0. Cool. Okay, question 14 is all about factorising. Part A wants us to factorise fully 12p cubed r minus 18p q squared r squared and 24 p q squared r. Okay, so the trick to this is go through and deal with one part at a time. So, first of all, let's do the normal numbers. So what's the highest common factor between 12, 18 and 24? It's 6. So we're going to take a 6 out. Now that's going to leave us with 2p q cubed r minus 3p q squared r squared. Add 4 p q squared r. Okay, next let's deal with the p's. So we got a p, we got a p, and we've got a p. So there's a common factor of p. So we take that out the front as well. So we get 6p times 2 q cubed r minus 3 q squared r squared. Add 4 q squared r. Next up, do the cubes. So we got a q cubed, we've got a q squared, and we got a q squared. So the highest factor of q is q squared. So that comes out the front as well. So now we got 6pq squared times 2qr minus 3r squared. Add 4r. Okay, then finally do the r's. So we got an r squared, and an r. So the highest common factor of r is r. So we got 6p q squared r times 2q minus 3r. Add 4. Cool. So that's our answer. Nothing else we can do there. Part B wants us to factorise fully. 6 lots of y add 3 to the power of 5 and 4 lots of y add 3 to the power of 4. Giving our answer in its simplest form, you do not attempt to expand the brackets. So that's good, because we don't want to do that. So we have a common factor of y plus 3. Now in fact, we have a common factor of y plus 3 to the power of 4. So we're going to get y add 3 to the power of 4 times. So we're going to get left with this 6, and then times y add 3 to the power of 1. And then we're going to get left with just a plus 4. So if we expanded that back out, we would end up with what we started with. So it's factorised. Now then, we can sort out the stuff inside of the square brackets. So if we expand 6y add 3, we get 6y add 18 add 4. So then we got y add 3 to the power of 4 times 6y add 22. Now 6y add 22 has a common factor of 2. So we can bring a 2 out the front. Remember, we are fully factorising. So we get a 2 out the front. Y add 3 to the power of 4 times 3y add 11. Job done. Cool. Okay, then part C. Factorise fully. 48 minus 75x squared. Okay, so this almost looks like a difference of two squares, except 48 and 75 are not square numbers. However, there's a common factor of 3. So if we take that out, we got 3 lots, 16 minus 25x squared. Now that bracket is a square number minus a square number. So that's going to factorise to 3 lots, 4 add 5x times 4 minus 5x. And that is our answer. Cool. Okay, question 15, another big one. 4 marks. Answers to work out the rate of change of y with respect to x. At the point on the curve y equals x squared times x squared minus 9 when x is minus 2. We must show our work. So, rate of change means gradient. So, what we need to do is differentiate y with respect to x and substitute in x equals minus 2. So, rate of change is a gradient. dy over dx gives us the gradient function. You can find the gradient at the point by substituting in the x coordinate. So, first off, let's rewrite y. So, x squared times x squared minus 9 is x to the power of 4 minus 9x squared. So, dy by dx, which is our rate of change of y with respect to x, it's going to be the power of 4 comes down and decreases by 1. So we get 4x cubed, and then for 9x squared, the 2 comes down, multiplies the 9, so we get minus 18x, and the power of 2 decreases by 1 to 1. So it's just minus 18x. So that is the general expression for the gradient of the curve. Now to find the gradient at the point when x is equal to 2, minus 2, we substitute in x equals minus 2. So x equals minus 2 gives us dy over dx is 4 times minus 8 minus 18 times minus 2. So that gives us minus 32 add 36. which gives us 4. Cool. Okay, question 16, 4 marks again. So, A is 2 minus 5x, B is 3x minus 1, C is x squared. We want to show that 2a add 3b all squared is identical to a plus b plus c. Okay, so let's do the right hand side first because it looks nicer. So a plus b plus c is 2 minus 5x and 3x minus 1 add x squared. So that's going to give us x squared. Now we got minus 5x and 3x, so that's minus 2x. And then we've got 2 add 1. There we go, so we got 2 minus 1, so that's going to give us plus 1. So that's the right hand side. Now if we look at the left hand side, we need 2a, so 2a is going to be 4 minus 10x, three b is going to be 9x minus 3, so 2a add 3b is going to be, so we got minus 10x add 9x, so that's going to give us minus x, and we're going to have 4 minus 3, so that's going to be 1 minus x. Now we want 2a add 3b squared. So if we square this bracket, we get, remember this means 1 minus x times 1 minus x, so we are going to get 1 minus x add x squared, which is x squared minus 2x add 1, which is equal to a add b add c. Job done. Question 17, we got circles and tangents. Check out my playlist down below. So, in circle, as equation, x squared and y squared is 29. B is the point, minus 5, 2. We want to show that P lies on the circle. So, what we do is substitute the coordinates into x squared and y squared. So, when x is minus 5 and y is 2, x squared and y squared is equal to minus 5 squared is 25, 2 squared is 4, 25 and 4 is 29. So they satisfy the equation, they lie on the circle. Okay, then for part B, we tell the tangent of the circle at P intersects the x-axis at point Q. Work out the x-coordinate of Q. You must show your working. So, 4 marks again. Right, a sketch with this one would be a good idea. So, we got a circle. Now we know because it's of the form x squared add y squared that we are centered at the origin. So 0, 0. So the center of the circle is here. Now we also know that the point P has coordinates -5, 2. So we can say that P is somewhere around here, and its coordinates are -5, 2. So the tangent is going to look something like that. So what we need to find is the x-coordinate of this point. So the way that we do that is we first of all need a circle theorem. So a radius and a tangent meet at 90 degrees. So they are perpendicular. So if we draw a radius from the centre to point P, we know two pairs of coordinates on the radius. So when lines are perpendicular, their gradients multiply together to -1. So if we find the gradient of the radius, we can find the gradient of the tangent. So I like to call my gradient of the radius R. So gradient is difference in y over difference in x. So we're going to get 2 minus 0 over -5 minus 0, which is -2 fifths. Now, a nice little trick to get the gradient of the tangent, it's going to be the opposite sign, so it's going to be positive, and we just flip the fraction. So the gradient of the tangent is 5 halves. So then, using y equals mx add c, we now know the gradient of the tangent is 5 halves. So the tangent is of the form 5 halves x add c. Now we need to find the value of c. To do that, we substitute in the coordinates that we know are on the line. So x is -5, y is 2. So that's going to give us 2 is equal to 5 halves times -5 is -25 over 2. Add c. So 2 is 4 halves. So we're going to add 25 halves to both sides. So we get c is 29 halves. So now we know the equation of a tangent is y is equal to 5 halves x add 29 halves. Now at q on the x-axis, y is equal to 0. So at q, y is 0. Substitute that into our tangent, we get 0 is 5 halves x, add 29 halves, and then we need to solve that for x. So we can multiply through by 2, so 0 is 5x, add 29, take the 29 away, minus 29 is equal to 5x. Finally, divide by 5, we get minus 29 over 5 is equal to x. Cool. Okay, question 18, we got inequalities, so we want to work out all of the integer values of x, so whole numbers, for which 4x add 3 is greater than minus 5, but less than or equal to 13. So, we basically need to end up with an x in the middle. So if we take away 3 from everything, we get minus 8 is less than 4x is less than or equal to 10. Then divide through by 4, we get minus 2 is less than x is less than or equal to 2.5. So the integer values of x, it's not allowed to be minus 2, but it can be minus 1, 0, 1, and 2. Cool. Part B wants us to work out the range of values of x for which x squared minus 11x and 28 is greater than 0. How many marks are they giving us for this then? 3. Okay, so it's a quadratic inequality. What we do is we sketch the graph. To be able to sketch the graph, we need to work out the x-intercepts. So first of all, set the quadratic equal to 0. Now to find the x-intercepts, we factorize. So two numbers that add together to minus 11 multiply to positive 28 are going to be minus 4 and minus 7. So that tells us then x is equal to 4 and x is equal to 7. So we can now sketch the graph. So we know the x-intercepts are at positive 4, positive 7. So something like that. I know the order of numbers, right, and then the 7 over that. Okay, so the question wants us to solve the quadratic greater than 0. So what that means is, what values of x produce the parts of the graph above the x-axis. So, parts of the graph that we are interested in are this bit and this bit. So, the x values that produce this left-hand part are all to the left of 4. So this is x is less than 4, has to be strict, it's not allowed to equal 0. And over here, everything to the right of 7. So x is greater than 7. So our solutions are x is less than 4 and x greater than 7. Cool. In question 19 we have transformations with matrices. Yay! So, used matrix multiplication to show that in the xy plane, a reflection in the line y equals minus x, followed by a rotation 90 degrees anticlockwise about the origin, followed by a reflection in the x-axis, is equivalent to a transformation by the identity matrix. So, if you transform something by the identity matrix, it doesn't change. It's like multiplying a number by 1. So the first thing I think we should look out for here is that the identity matrix, call it I, is 1, 0, 0, 1. Like that. Okay, now then, let's go through each of these transformations and find the matrix that would cause it. So, we always start with these 2 points, 1, 0 and 0, 1. Now we put these points together in a matrix, so we always put 1, 0 first, so that's this guy, and then 0, 1. And then we see where these 2 points would move through the transformation. So the line y equals minus x looks like this. So this point is going to reflect to there, which is 0, minus 1. So in our transformation matrix, that's the first column. And then this guy reflects down to there, which is going to be minus 1, 0. So that's the other column in our matrix. So that is the reflection in the line y equals minus x. So that's the reflection. Okay, next, let's do the rotation. So it's 90 degrees anticlockwise about the origin. So what's going to happen here is 1, 0. It's going to rotate to 0, 1. So that's the first column. And then 0, 1, it's going to rotate to minus 1, 0. So that is our second column. Now, before we worry about the reflection in the x-axis, we can now find the matrix given by the reflection through y is minus x, and then the rotation about the origin. So what we do there is we start with the reflection, so let's say the reflection in y equals minus x, followed by rotation 90 degrees anti-clockwise. Well, we start with the first matrix, so this one, for the reflection, so 0 minus 1, minus 1, 0. Now we multiply that at the front by the matrix for the rotation. So by 0, 1, minus 1, 0. Okay, so if we multiply these two together, so for this, we do first column of the second times first row of the first. So we're going to get 0 times 0, add minus 1 times minus 1. So that's going to give us 1. And then we do the second column of the second matrix times the top row of the first. So then we're going to get minus 1 times 0, which is 0, add minus 1 times 0, which is 0 again. And for the bottom left, we do the first column of the second matrix times the bottom row of the first. So we're going to get 0 times 1, add 0 times minus 1. So that's 0. And then for the bottom right, we do the second column of the second matrix times the bottom row of the first. So we're going to get minus 1 times 1, add 0 times 0, which is minus 1. So that, at the moment, is the matrix for the reflection, followed by the rotation. Now let's find the matrix for the reflection through the x-axis. So 1, 0 is going to stay at 1, 0. 0, 1 is going to reflect down to 0, minus 1. So our matrix for this is 1, 0, 0, minus 1. So then we're doing that matrix times this matrix. So 1, 0, 0, minus 1. So 1, 0, 0, minus 1 is multiplying the exact same matrix. So that is going to give us, well, top left, we're going to get 1 times 1 and 0 times 0, which is 1. Top right, we get 0 times 1 and 0 times minus 1, that's 0. Bottom left, we get 1 times 0, add 0 times minus 1, that's 0. Bottom right, we get 0 times 0, add minus 1 times minus 1, which is 1. Now that is the identity matrix. So, we've shown it. Cool. Okay, question 20, we got some trigonometry inside a 3D shape. Good times. So PQRSTU is a triangular prism. We're told PQRS is a rectangle and angle QRU is 90 degrees. So that's just telling us the base is a rectangle and the height over here is perpendicular. So RU is vertical. PQ is 10, QR is 12, UR is 7, so on the diagram, M is the midpoint of PQ. So M there is the midpoint of that line. Now we want to find for part A the size of the angle between the line UM and the plane PQRS. So the line UM goes from M, now it's going up the slanty side of the prism, like that. We're also going to need then so that's the line. Now the plane PQRS is just the rectangular base. So the base of this triangle is going to run along the base of the prism, like that, and then the height of the triangle is that guy. So let's make a sketch of that triangle outside of the prism. So we got our height, which we know is 7. We've got the base, R, and then we got the hypotenuse, which is the line MU. Okay, so the angle that we need is this guy. So this is the angle that we want. Let's call it theta. Now, to be able to work that out, we need one of the other two lengths of this triangle. So probably the easiest to get is the red one. So let's build out a rectangle as well for the base. Okay, so imagine we're looking down on the base. So we got P, Q, R, back right, and S over there. Now, the red line goes from M there back to R. Now that also forms a right angle triangle. So we know the length QR is 12. So this length here is 12. And we know that MQ is half of PQ. So that's 5. It's nice, it's going to work out as a whole number. So now using Pythagoras, if we call this C, we know then that 5 squared add 12 squared is C squared. 5 squared add 12 squared is 169. So C squared is 169. So C is root 169, which is 13. So now we know two lengths on this triangle. So now it's just a game of SOHCAHTOA. So we got the opposite and the adjacent. So it's a job for tan. So tan theta is equal to opposite 7 over adjacent 13. And then to get theta, we inverse tan 7 over 13. And we get theta is 28.3 degrees. Cool. Okay, then part B for 2 marks. It wants us to calculate the size of the angle between the planes UMR and UQR. Okay, so UMR is the triangle that we've just drawn in red, green and blue. UQR is the side of the prism. So what we want is the angle between the red line and the side of the prism. So again, let's put out a rectangle. So we know the length of the shape is 12. And the width is 10. All that we need to do is find the angle between MR, so between MR and QR. So all that we need is this angle here. Imagine we were looking down from above. The red line is one of the triangular planes and the side of the rectangle here is the other plane. So we just need this angle. So let's call it theta again. So again we got the opposite and adjacent. We know this length is 5. So we know this time tan of theta is 5/12. So theta is the inverse tan of 5/12, which gives us theta is 22.6 degrees. Cool. Okay, question 21. The continuous curve y equals f of x has exactly 2 stationary points. Stationary points are where gradient is equal to 0. So if gradient is equal to 0, that means dy by dx is equal to 0. Here is some information about the curve. So when x is less than minus 1, dy by dx is positive. So that means a positive gradient. So that means the curve is going up from left to right. When x is minus 1, dy by dx is 0. So that means this is a point where gradient is 0. So it's not going up or down. So this is a stationary point. Now when x is between minus 1 and 2, dy by dx is negative. So the gradient of the graph is going down from left to right. when x is equal to 2, dy by dx is 0, so that means this is a stationary point. So there's no gradient. Let's try that again. So it's horizontal. And then when x is greater than 2, dy by dx is negative again. So that means the curve is going down from left to right. So we're also told that f of minus 1 is 3 and f of 2 is 1. Now what that means is when x is minus 1, remember that y is equal to f of x. So y is equal to 3. And when x is equal to 2, y is equal to 1. So the question says to state the coordinates and the nature of each of the stationary points. Okay, so let's just sketch how this curve looks. So it starts off going up from left to right, stationary point goes down, then we get a stationary point and then it carries on going down again. So we know this stationary point happens when x is equal to minus 1. Now when x is minus 1, we know y is 3. Now we can see that is a maximum. So minus 1, 3 is a maximum. And then the other one happens when x is equal to 2 and y is equal to 1. Now we can see there that the graph on the left and right is negative. So that means this is a point of inflection. Cool. Okay, question 22, we got trigonometry. So part A, we are told that 8 cos of x and 5 sine of x is equal to 0, where x is between 90 and 180 degrees. Work out the size of angle x. Okay, so we are given two trig identities on the formula page. So with trig equations, you need to get everything in terms of one trig function. So it's a problem that we got sine and cos. Now the identity that we need, well, we could actually use both or either one, but the easiest one is going to be tan of x is equal to sine of x over cos of x. So, if we've got 8 cos x, add 5 sine x is equal to 0. If we divide through by cos of x, we get 8. Add 5 sine of x over cos of x is equal to 0. So we got 8 add 5 tan of x is equal to 0. Take away the 8. 5 tan of x is equal to minus 8. Divide by 5. Tan of x is minus 8 over 5, which is minus 1.6. Now, if we inverse tan minus 1.6, our calculators give us basically minus 58 degrees. Minus 57.99 minus 58 would be fine. So, now then, that is not the answer, because we want x in the region or between 90 and 180. So, if we have a look at the time graph, it's a bit mental. So we have these things called asymptotes. Now they happen at minus 90 and 90 and every 180 degrees later. So we want our solution to be between 90 degrees and 180, which is that. Now, the one that we've got over here is minus 58, which is about there. So what we need to do is carry on over here, where this line is the line y equals minus 1.6. Now, tan has a period of 180 degrees. That means to get from solution to solution, you add 180 degrees. So the x that we want is minus 58 add 180, which is going to give us 122 degrees. So x is 122. Go. Okay, then for part B, we are told that 6 sine squared x add 4 cos squared x is identical to A add B cos squared of x, where A and B are integers. We want to work out the values of A and B. So, the other identity that we're given is that sine squared x add cos squared x is equal to 1. Now we notice in the right hand side we have a cos squared x and no sine squared x. So we want to get rid of sine squared x. So we can say then that sine squared x is equal to 1 minus cos squared of x. So 6 sine squared x add 4 cos squared of x is equal to 6 times 1 minus cos squared of x add 4 cos squared of x. Now if we expand these brackets, we get 6 minus 6 cos squared of x add 4 cos squared of x. So minus 6 add 4 is minus 2. So we get 6 minus 2 cos squared of x. Now one thing I'm going to point out here is that I know when questions show something like this, where you've got a add b cos squared of x, and we've got a negative amount of cos squared, people go, that can't be right, because up here we got a plus b. All that means is that b is equal to minus 2. So a is 6, b is minus 2. Cool. Okay, question 23, nearly there, which is good, because I'm tired. So, for each of these two function machines, when the input is A, the output is B. So we're told that K is greater than 0 and not equal to 1, and A is greater than 0. So with the first one, we put in A, square it, add 3, multiply by K, and we get B. Second one, we put in A, multiply by K, square, add 3, and we get B. Work out an expression for A in terms of K, giving your answer in its simplest form. Okay, so let's call these guys 1 and 2. So, in 1, well, if we go through it, we put in A, we square it, and that gives us A squared. We then add 3, that gives us A squared add 3. We then multiply by K, so that's going to give us KA squared add 3K, and that is equal to B. So we can say that KA squared add 3K is equal to B. Now by the second one, we put A in, multiply by K, so that gives us KA. We square it, so that gives us K squared, A squared. We add 3, so we get K squared, A squared, add 3, and that is equal to B. So we got K squared, A squared, add 3 is equal to B. Now, these equations are simultaneous, so we want an expression for A in terms of K. So we need B to bugger off. So, to get rid of the B's, we're going to subtract one equation from the other. So let's do 1 minus 2. So that's going to give us Ka squared add 3K minus K squared A squared minus 3 is equal to 0. Now what we need to do, because we want an expression for A in terms of K, we need to make A the subject. So let's get rid of that 3. So add that to both sides, we get K A squared add 3k minus k squared a squared is equal to 3. Okay, now everything on the left has a common factor of k. So let's divide through by k. So we're going to get a squared add 3 minus k a squared is equal to 3 over k. Now we got two a squared terms, so we got a squared minus k a squared. Add 3 is equal to 3 over k. Now we can factorise those two a squared terms to get a squared times 1 minus k. Add 3 is equal to 3 over k. Let's get rid of that 3. So a squared times 1 minus k is equal to 3 over k minus 3. Now let's go for turning the right hand side into a single term, so into a single fraction. So if we go for common denominators, we need to multiply minus 3 by k over k. So this right hand side is 3 minus 3k over k. Okay, so now we know a squared times 1 minus k is equal to 3 minus 3k all over k. Now, on the right, up on top, we have a common factor of 3. So we can write that as a squared times 1 minus k is equal to 3 lots of 1 minus k all over k. Now that is now really nice. Both sides have a common factor of 1 minus k. So now we divide that away and we get a squared is equal to 3 over k. So a is root 3 over k. We don't need to worry about plus or minus, because remember we were told a is greater than 0. Cool. Question 24, the final question. We want to work out the value of p when 9 to the 0.5p times 81 is equal to 27 to the 2p minus 1. Right, so we need to get an equation in terms of p, which, okay, we do have at the moment. What I mean is that we need to get everything, all of the base numbers, we need to be the same. So then, what I mean by base numbers are at the moment 9, 81 and 27. So all of those are powers of 3. So 9 is 3 squared. So we got 3 squared to the 0.5p times 81 is 3 to the power of 4, and 27 is 3 cubed. So now everything is in terms of 3. We can sort out the indices. So remember, when powers are separated by a bracket, they multiply together. So 3 squared to the 0.5p is 3 to the p. 2 times 0.5 is 1 times 3 to the 4 is equal to 3 times 2p minus 1 is 6p minus 3. So we get 3 to the 6p minus 3. On the left, we can combine the terms by adding the powers. So we get 3 to the p add 4 is equal to 3 to the 6p minus 3. So this is now what I meant by an equation in terms of p. Both sides have 3 as a base. We know they're equal, so the powers must be the same. So p add 4 is equal to 6p minus 3. Now we just need to solve for p. So let's take p away. So we get 4 is equal to 5p minus 3. Add 3, 7 is equal to 5p. Divide by 5. P is equal to 7 fifths, or 1.4. Cool. And with that, guys, the paper is done. I hope you found this useful. Don't forget to give us a thumbs up, get subscribed. Good luck in your exams. Take care. Take it easy.